Welcome to our Fresh Think podcast. My name is Pedro Ladiera. I'm a mining consultant for Snowden Optiro, and today I'll be joined by Tarrant Elkington, our general manager of Snowden Optiro, expert in mine optimizations, and my boss. Welcome, Tarrant.
Thanks, Pedro. Good to be here. Nice to be on the other side of the desk this time.
Great. So let's talk about mining planning. And the topic today will be vertical rate of advance, VRA. So Tarrant, can you explain what is the vertical rate of advance and the impact in the mining planning?
Sure. So vertical rate of advance is actually a really important hidden sort of parameter in mine planning. And it basically involves how quickly we can mine a cutback. Typically, it is measured in number of benches that we could mine over a period of time, which is typically a year, or it might be measured in a total amount of tonnage that we can mine from a cutback in a year. But how quickly can we progress through that cutback? And that's important because, generally speaking, when we mine a cutback, we are mining through waste first and then getting to the ore. So it determines how long we need to incur cost for before we start getting to the good stuff and getting the revenue.
Great. And what are the implications? You have a higher or a low vertical rate of advance in the mining planning and the mining project?
Yeah. So if you let's look at the two ways. So if you have a low vertical rate of advance, it means that you can't drop down through your mine very quickly. So that means each cutback that you have needs to be mined slower. So the tonnage you've got coming out of that cutback is lower. If you want to achieve the same production level, it means you need to have more cutbacks operating at a time, more operating area, and potentially usually what it means is you're mining more waste earlier in the schedule to try to achieve your ore profile. If you have a high rate of advance, I guess it's the other way around. So it means you're turning over these cutbacks, mining less of them at the same time. Also means more of your equipment is in a more confined area. So, but it does mean that you get to defer some waste, which is cost.
Yeah.
So which is really important.
So let's go deep on the VRA. So do you reckon that the VRA changes by commodity type or mining method?
Well, obviously we're thinking open pit, hard rock mining here. So it definitely does vary from project to project for sure. There are certain characteristics that drive that. So if some mines need a higher vertical rate of advance, and also some mines have a different size of equipment, and they have a different mining cycle. So if you need to do detailed drill and blast, if you have significant dewatering requirements, then you'll advance more slowly because you have more activities going on in a bench and less space for your equipment to operate. So there's sort of like, surface level deposits that are quite shallow, but in clays and things like that will advance quite reasonably slowly, but they don't really need to. Whereas if you're mining through, let's say, waste, when you have less grade control, upper benches might be drier, etc. With larger equipment, then you can advance quicker. If you are looking at a more selective mining on a bench, smaller blasts, things like that. So when you're in the ore, then you might slow down. So it might change within a cutback from when you start it to the bottom. So it's dependent on all of those things. And when we talk about mining, is it a particular commodity? Well, the commodity sort of drives the geometry and the mining cycle. So yeah, that all flows on.
And from your experience, what's the range of this VRA that we normally apply in the mining projects?
Well, in my experience, probably the range, if I used meters rather than benches, but on the low end, probably like very low is 30 meters. And on the upper end, maybe 150 meters has been achieved, in the big porphyry, porphyries in South America, for example. They're quite routinely achieving more than 120 meters per year. I know in West Africa, cutbacks are mined at, and here in Australia, I've seen examples where people have achieved 150. I haven't seen much more than that. But if we think about like a nickel laterite or something like that, shallow deposit, 30 meters maybe what is achieved, but they don't really, might not need to mine much faster than that.
Yeah, looks like we can vary a lot from different types of mines, commodities, and operations and mining methods.
Yeah.
So, what's the key points that you reckon that drive this VRA, and what is important to take in consideration?
Well, I think obviously the bench height that you have is important. So, and the size of equipment. So each cut we go through with bigger equipment, we can get through more sort of more material, right? Yeah. So I think we expect generally in terms of meters per year that we could achieve more with bigger equipment. If you have the need for detailed grade control or small blasts or whatever, that's going to slow you down. So when you get into the ore, people generally don't operate much more than, say, 60 vertical meters in a year in ore, because you want to extract that carefully. But if you're in waste, then you can go much higher. I've seen, like, I suppose a couple of interesting things really is that often I've seen mines achieve high rates of a vertical advance when they need to. So let's say you have a potential shortfall in ore because you haven't stripped enough waste in the past, and you need to get through that waste to get, to meet your production targets. I've seen amazing things happen, right? So that's that's a factor that's at play here.
Yeah, let's get some examples for like new projects and existing projects.
Sure.
Like in a new project, would you define a vertical rate of advance, or would you test it? Like how you would set up this vertical rate of advance in a new project?
Well, I guess that's a really good question, because I'm still searching for the best, way to model this, right? And so I think there's certain, starting points or benchmarks that you should start for, because if you plan for too high a vertical rate of advance that you're never going to achieve, then you're setting the project up for failure, because ultimately, if you plan too high and you don't achieve it, you're going to have a shortfall of ore, right? And that's not a good thing. So you want to start at a reasonable level before you've demonstrated that you can achieve sort of best practice turning over benches really, really quickly. So, you would tend to start out, for a typical mine that needs it maybe, no more like 100 meters max, right? But the other possibility is to turn it around and say, what vertical rate of advance does a mine need to be successful? Because you don't always need to mine cutbacks as fast as they can, particularly when you're in ore, because if you're in ore, you've only got a certain production rate that you need to match. So there might not be any point in mining, 3 times the amount of ore that you need to by advancing faster. So that's usually one good thing is, and I always think in mine optimization, like set the thing free, see what it wants, say what it wants to do as if it is a thing, but, see what it wants to do in order to maximize value. And then let's analyze the results. There might only be like 1 or 2 cutbacks where it's sort of spiking.
Yeah.
And you say, oh, okay, well, what does that mean, for what I'm doing? And for those ones that do require the high rate of a vertical advance, is that an opportunity to adjust the design? Maybe we could split the cut back to so that it doesn't, need to push so fast or something like that.
Yeah, nice. Sounds a dynamic process, just understanding the ore body, understanding the pits as you are progressing your mining planning, and see what will be required as a vertical rate of advance, and what will be a benchmark and to use that. But for existing operations, like, do you recommend to use some historical data for this rate?
Yeah, it's much better for existing projects. If you want to use a high rate of vertical advance, 120 meters per year, but you've achieved it, right?
Yeah.
Then you've demonstrated that you can do it. Then that's the best benchmark that you can have. It's its own operation, and this is really, I think, for operators. I think we have a large gap in data that is collected relating to this, and it would be great to be able to see this data, produced for, and I can explain why that is a bit tricky, but actually holding a database of this information, because it is such an important driver of how much waste and ore that you're mining. But yeah, for sure, the past history is good. I wouldn't necessarily say, if we took every bench and we said, well, every pushback, and some pushbacks we were doing 100 and some we were doing 40, should we use the average of 70, right? The answer is, to me, is no. Because not every cutback you need to mine, if you use empirical data, not every pushback is being pushed as hard as it can. So we're looking for the limit that we're trying to model, not the sort of average performance. And so we don't want to just use the average of what we've done in the past. Yeah. It's kind of like looking at the upper limit of it.
Yeah. Yeah, like I imagine that if a project has already reached a level of VRA, like a maximum level, like 100 meters, we definitely could take into consideration that it's possible to do. But would you keep the plan on these 100, or you try to balance it to reduce the risk of not achieve this VRA?
I think you always want to understand the sensitivity, okay, right? Because this is a number that is very difficult to prove. Like, you could do it, try to do it with simulation, things like that, but it's very, very difficult to model all of the aspects that go on in a mine for it. So yes, ideally we would want to knock it down from world's best practice down to something a bit more achievable, but if that is necessary in order to hit your targets, then I guess that just needs to be declared. And and as I've seen sometimes, what are the critical success factors for this plan? It needs to be front. If you're going to try to go world's best practice, highest, you need to make that clear that is a priority. And I've seen in certain circumstances where people do need to advance, they do. There might be additional costs involved. So say grade control. Rather than doing grade control as part of the mining cycle, you do it 12 months in advance. So that you're that's out of the way in terms of your mining cycle, and you can you remove that aspect and you can advance faster.
Yeah. So yeah, it looks like that really hard to define the VRA. And is there any source that you recommend to the listeners to search about what will be a VRA applicable for their projects?
Look, I think there's definitely room. Like, it'd be great for people, researchers, get companies together to provide some data. We've been working with some clients, to try to gather some of that data for their own operations. That in the public domain, there's a great couple of articles by Julian Ponowarowski, and which we can put in the show notes, who does gather some information and does provide some really good insights, looking at the bench size, versus the vertical rate of advance. So the bigger benches, how many benches per annum, and he does it for sort of a small, medium, and large, and he captures the great, point that I was trying to make before in terms of, it's not about the average, it's about what's the maximum that's achievable for a bench that is a certain size for an operation. So I think that's definitely a good one to look at, and for us as an industry to try to advance upon adding all of the other factors and aspects that we've talked about.
And would you recommend, like, after the mining planning, after your study, recommend to validate this vertical rate of advance with some simulations, or do you reckon that there is a lot of detail? What's your thoughts about that?
Yeah, I think I think simulation, discrete event simulation, where you sort of plot out the little trucks running on like ants in the mine in advance, try to model all of the mining cycle. I think if you're trying to push the limits, you're trying to say world's best practice, then that is, other than benchmarking and, where we can be as good as them, that's one way to do it. But it is a large amount of effort, so it's a large amount of effort and cost for people to go about doing. And, in my experience, it's very sensitive to the inputs, and sometimes it's very hard to model all of the weird things that can go on in a mining operation that might derate the performance. I think if you're assuming very high vertical rates of advance, you probably, from the outset, it's possible that you might have sized your project too big, and maybe something a bit smaller and the higher margin might be more appropriate and more, able to prove if you want to go and get financing, and we've talked about this in other podcasts, but if you want to go and get financing and this might stand out as a major risk, that if you can't achieve these targets, then you won't achieve the plan, then maybe it's worth toning them back. Then once you get into the operation and you can push it and you can prove that you can do it, then go for it,
Yeah. Understanding the sensitive of this parameter to the mine operation, I think that it's critical to see if we need to spend more time and effort with additional systems.
Yeah, what's your experience of that?
I share the same thoughts than you in terms of I guess that the VRA it's critical in the mining plans. I think that some of the projects the VRA can change definitely the result and which pushback or which cutback we are starting to mine, and would like to spend the next years to get the best NPV for the project. And it's interesting how one simple rate can change the direction of the mining plan, the sequence, and maximize the return of this project. So it's really good. So thanks so much for these insights today, Tarrant. Was really good. I hope that you've enjoyed our podcast, and stay tuned for more podcasts like that. And if you like this content, please leave your comments on that, and we'll try to create and gather more information for you. Thanks so much. See you.